What's up guys, Shawnthebro here, and in today's episode of the fighting game tutorial series, we are going to continue upgrading our camera, converting it to the code camera. That way we can use it and edit it in the code. We'll still have the blueprint counterparts and everything in there will still be functional, but we want to allow us some more usefulness on our camera because we have a lot more functionality for it now. So as we come into our game here, everything is functioning as normal. We haven't made the change from any of our blueprint camera items to the code classes we made. Before we do, if you want to get caught up in the series and check out everything we have to offer from our hitboxes, our camera, and our online play, then feel free to click this icon in the top right corner right here to check out the entire playlist of the fighting game tutorial series. Alternatively, if you don't care about that, you just care about the camera, then I recommend you watch this episode right here in the top right corner, which is where we initially set up our fighting game camera, and that's important because we're using that logic today and expanding upon it while we're converting it to code. So we're not just converting it to code, we're also making the camera better along the way. With all that out of the way, we can go ahead and get started. So this is a code and blueprint tutorial series, but today we're mainly going to be transferring stuff from the blueprints. First thing I want to do is cover some of the stuff that we did not cover for the camera edge in the previous episode, which is really just making sure these components we made in the code are a U property. That way we can see them and access them properly in the blueprint when we do parent this class to the code class. So to do that, we can go to our code and go to base camera edge.h, and in here we had two components, our box collision component and our static mesh component. I've copied the U property from the character class because components are always a little bit trickier. They have more fields in here typically by Unreal standards. Unreal likes to make them visible anywhere, blueprint read only, and then give them their category. Like this, and then have this meta tag to allow private access on them because you'll notice that we created them under the protected space. You don't have to follow this, and I don't always follow it, but I think starting out for converting this from blueprint to code, we should follow the Unreal standard for this. Then we can edit it as we need it. So for both our components, let's go ahead and add this U property. Visible anywhere allows us to access this from other things, such as in the blueprint. And blueprint read only is going to make sure that we can't edit this component. We can only read the values on it. We can still set this up to edit the default values only. That means we just can't change it while we're in the graph. Again, we don't really need it to be read only. Category can be camera, or you could make it camera edge, whatever. And then meta equals allow private access equals true. This is good because when we're in protected or private, we want to be able to use these U properties successfully, and allowing this allow private access equals true section will allow us to do that. So this is a good upgrade from the previous episode, and there's one other thing I want to do here, and that is update this hitbox collision function. There's a few things I want to do to it. First of all, I want to change it from hitbox collision to on hitbox collision. And the reason I'm doing this is because, first of all, hitbox means something very specific in our fighter. Even though this is a box collision, saying hitbox next to each other does make it a little confusing, at least when I'm saying it. So I think calling this on hit and then box collision makes this a little bit easier to understand. Now, when we rename this, we do need to go to our base camera edge.cpp and make sure we rename it everywhere as well. So in the add dynamic call, we change this from hitbox collision to on hitbox collision, and the function name itself from hitbox collision to on hitbox collision. Additionally, you could make a U function that is blueprint callable for certain elements of the blueprint version of this class. The camera edge BP have collisions that could call that instead. I'm not going to do that here, but just note that that is something you can do. Next thing I want to do is implement the use camera function in our base camera BP. So if we go to our event graph, use camera is up here. The main reason we implemented the camera edges in code was so that we could spawn our camera edges for our camera code class. And so our main focus for today's episode is implementing the use camera event, which if you notice is one of our last events and the next biggest event that we have before our camera conversion is complete. So even though it's an event here, we can just make it a function. So if we go into base camera.h, we can make a new function. I'm actually going to put it right below begin play. The camera has been activated or set to be the used camera. So we will make this one a U function, blueprint callable. That way we can call it from the blueprint, and we're going to call it void use camera. So there we go. Let's go to base camera.cpp and scroll down below begin play. Void a base camera, use camera. And there we go. Now we can start filling it out from what's in the blueprint. Now we don't actually need to do this first part here because this is just setting our game mode reference. In our other functions like is team 1 character on left and tick, we were checking for the game mode and the game mode's type in those functions. We don't need to actually set a reference here. So I'm going to skip these nodes that's already been handled in the other functions. So the first nodes that we have to implement in use camera are the set view target with blend node. It comes from the player controller. To get set view target with blend in the code, what we need is a player controller. And we know this because the target is player controller. So we can type a player controller, pointer, default player controller, and I'm calling this because we're going to get the first player controller that we find in this case. There's something called gameplay statics, which will allow us to get the first player controller. We're going to need to include something for this. So if we go up to the top, include kismet / gameplay statics.h. Now, including this file will allow us to access gameplay statics, which we're going to need down here. So we have gameplay statics : and then we can type get player controller, just like this. And this function will take in the context. So when we're taking in a context on anything, we just need to pass an object from the world or the world itself so that this object knows where to look. And so for the context for the player controller, we can pass in get world, and then we need the player index, and since this is the default player controller, I'm just looking for index 0. This should get our initial player controller. We can even put this in an if statement if we want. So if all of this, and now if this is valid, our default player controller is valid. If our default player controller is valid, then we know we have this node right here, get player controller with player index 0. So we can drag off of this to search for set view target with blend. Default player controller set view target with blend. And we have a few parameters here. The first one is the new view target, which is going to be self. In code, that is this. Then we also have the blend time, the view target blend function, blend exponent, and block outgoing false. We have all these here, but everything here is default. And you'll notice that in this function, these are all optional parameters. So I can just pass in this and everything else will go to its default value. So now we're setting view target with blend in use camera. These nodes are now done. Next thing we do is spawn our camera edges and set the references to them. We do this for left, right, left inner, and right inner. So after the player controller is valid and we set the view target with blend, we can go down here to spawn our camera edges. This is going to be the same process for all of them. We're going to use get world, spawn actor, and the parameters are going to be pretty similar to what we see here. So we're going to choose the type, the transform, the collision handling override, the instigator, and the owner. So when we do spawn actor, it is a templated type, so we need to pass in the type here, just like when doing a cast. So we're trying to spawn a type of camera edge. The camera doesn't know anything about the camera edges right now. So to do this, we need to make these variables. And so if we go to base camera.h, go one include above the generated include base camera edge.h. We now have that camera edge type. The C++ or the CPP file will include this now as well. And so spawn actor, a base camera edge. Instead of a transform, it's a location, a rotation. The others are completely optional, but we need that location and rotation. So we can just pass in this actor location, this actor rotation. So instead of using this, we can just do get actor location. So basically spawn it at the camera's location, get actor rotation, spawn at the camera actor's rotation, and we can do it just like this. When we spawn this actor, it's going to return an actor of the type we created, so we can set variables equal to this. We should make variables just like we did in the blueprint for left inner, left outer, and right outer edges. So if we go to the base camera.h and right here below our tick function, left outer edge. Simple enough. We can make these U property if we want. So edit anywhere, blueprint, read right. And this is going to be a base camera edge pointer, left outer edge. Say the left outer edge. All right, and then we can just follow this, copy paste this for each of these. So we're going to have our right outer edge. Then we're going to have our left inner edge. Then we're going to have our right inner camera edge. And we're going to spawn the 4 of these. So it doesn't really matter because we're just making some default values here. So left outer edge equals right outer edge equals left inner edge equals right inner edge equals. Now we have all 4 of these camera edges spawned. So that is actually all of this right here. And we do a few other things here, and we are going to do them, but I also have this behavior for the 3-dimensional boundaries, so the front and back camera edges, which are the same thing, for front outer edge and back outer edge. Let's go ahead and do that here. So let's go back to base camera.h, front outer camera edge, so this is going to be called front outer edge, and we're going to have a back outer edge as well. And we can go to the same function as before, copy this twice, and have front outer edge and back outer edge. To clean this up even more, we can set the default values for all these variables here. So left outer edge equals null pointer. Right outer edge equals null pointer. Left inner edge equals null pointer. Right inner edge equals null pointer. Front outer edge equals null pointer. And back outer edge equals null pointer. So that's set up for use camera. Determine and set inner boundaries. Let's just do inner boundaries for now. So the next thing we have is the set inner boundaries function, and that's what we'll be handling next. Anyway guys, thank you so much for watching. If you enjoyed this video and you're happy to keep converting the camera from blueprint to code to improve it, then please subscribe. It does more for myself and the channel than anything else you can do, and I really appreciate it. I want to give a huge shout out to my YouTube membership, Patreon, and Discord subscribers. You guys rock, and I am so appreciative of you. Thank you so much. If you ran into any problems while following this tutorial or any of my tutorials, feel free to join the Discord community. There's a link in the description, and I would be happy to assist. Thank you guys so much for watching. I'm Shawnthebro, and I'll see you in the next one. Goodbye, guys.